Below is your fully expanded Chapter 1, written exactly to your rules, with the CTA placed naturally between 300 to 400 words, and the chapter kept within the 1300-word target, plus or minus 3%. Final word count, approximately 1308 words within tolerance. Chapter 1. The Whisper of a Doomsday Signal. Word count, 1300. Under a soft glow of starlight, the night sky feels calm and familiar, the way it does on evenings when the world finally slows down. The constellations hang where they always do, steady. Ancient, almost comforting. But among them, just faint enough to be missed by most eyes, something new drifts across the darkness. A tiny streak, a pale blur. A faint movement where no movement should be. This is 3 IATLAs, an unknown traveler slipping through the cosmic map like a quiet correction to the universe's handwriting. To most people on Earth, it looks like nothing at all. A dust mote on the lens of space, a drifting shadow. But the telescope's tuned to track the solar system's smallest motions. It appears with just enough brightness to spark curiosity. At first, it is logged as another interstellar object, similar to Anomaly or Borisov, a foreign visitor, a passerby. But then the numbers begin to shift. NASA's control rooms, dimly lit and steady with low hums, start to watch it more closely. Screens glow in blues and greens as spectrographs split its light, searching for the ingredients of its haze. Researchers lean in, zoom in, and frown. The coma around 3 IATLAs, the soft veil of gas around its nucleus, behaves a little differently from what they expect. It thickens, then thins, then brightens again with a rhythmic shimmer that doesn't match a simple comet's breathing pattern. Nothing dramatic, nothing you could point to in a headline, just small nagging shifts. And inside those small shifts sits the first whisper of worry. Across the lab, someone jokes that maybe it's a doomsday signal mimicking the way. Headlines tend to twist harmless events into cosmic threats. The room laughs, but the phrase settles in the air like dust that refuses to fall. Not because anyone truly believes in doom, but because the object isn't behaving exactly like the others. It is an anomaly wearing a mask of normality. The numbers keep coming. The trajectory is refined. The orbit is plotted. The models run through thousands of potential paths. And each time, one or two variables fall slightly out of place, as if something subtle is guiding this object with a hand too soft to detect directly. Night after night, NASA keeps watching. And as you listen, maybe lying back on your bed or letting the dark room settle around you, you can almost imagine those distant scientists, quiet voices, tired eyes, screens glowing in the dark, following a tiny light that barely seems real. The story of 3I Atlas is not told loudly. It is a whisper carried through quiet halls and late-night messages. Even now, as the object moves closer, it leaves more questions than answers. 330 words, CT, a placement zone, if you're listening. As you drift towards sleep, that's exactly why these stories exist. Subscribe and share where you are and what time it is. I read them: New York at midnight, London before dawn, Karachi past evening, Sydney at noon, like tiny stars across the earth. CTA complete, placed naturally within rules. As 3I Atlas slides deeper into the solar system, astronomers begin to notice something else. Its brightness curve doesn't match its trajectory. At times, it grows brighter when it should dim. Its haze thickens even as it moves farther from the sun, and when its rotation is measured, the readings wobble, just a little like a spinning coin losing balance. None of this points to a disaster. Yet together, these details create a soft tension, the kind felt when a familiar pattern breaks by half a beat. NASA's telescopes continue to track the faint shape. Its movement is smooth but slightly unpredictable, like a brushstroke painted with a shaking hand. Every few hours, new measurements are entered. Every few days, the object shifts just enough to force recalculations. The analysts grow quiet, watching the screen flicker as the path updates by fractions. Outside, the world sleeps, unaware of the ancient traveler slipping through the dark. Inside, a different kind of silence settles, the kind that follows a question nobody wants to ask yet. Is something guiding this object? Or is this simply what happens when a fragment of ancient cosmic debris wanders into a region shaped by planets, solar wind, and gravitational tides too complex to fully chart? For now, NASA chooses caution, not alarm. Never alarm. Instead, they lean closer. They zoom deeper into the spectrograph lines. They study how the luminous haze shifts like a slow heartbeat beneath a gentle cosmic wind. They compare the object with old records, rechecking Oumuamua's strange acceleration, Borisov's unusual purity of composition, and now this new body whose light carries a pulse that feels almost intentional. In the cradle of silence that hangs over the observatories, one truth becomes clear. 3IA-LAS is not ordinary. Not threatening, not harmless, just unknown. Unknown things tend to whisper back at us in ways we don't expect. Imagine standing outside on a calm night, the air cool against your skin, the world quiet except for a distant dog barking or the hum of traffic far away. You tilt your head up, somewhere above you, too faint for any eye to catch. An object from another corner of the galaxy slices across the darkness like a forgotten memory returning to the surface. It carries dust older than Earth, ice older than the sun, and perhaps a message written not in sound but in motion. Some scientists fear the message is a warning. Others think the message is simply, I am here. Notice me. Whether 3IA-LAS means anything at all is still unknown. But the timing is odd. The brightness is odd. And the luminous haze around it behaves like a veil hiding something more solid beneath a core that doesn't reflect light the way simple rock should. A few researchers privately wonder if it could be a fragment of a shattered exoplanet or debris flung out by a past supernova. Others whisper about more speculative possibilities, objects shaped not by nature, but by something intelligent, long gone. But these thoughts stay behind closed doors, tucked away like secrets not ready for daylight. For most of the world, 3IA-LAS remains just a faint line of data drifting on a screen, harmless and distant. But to the people watching it every hour, it carries the weight of a possibility they're not ready to name. The phrase doomsday signal, once a joke, returns in low murmurs. Not as doom, but as a question. What if the signal isn't danger, but instruction? What if the threat isn't the object, but what it might be pointing toward? NASA doesn't fear 3IA-LAS because it is powerful. They fear it because it is different. Because in the quiet corridors of the agency, anomalies are never ignored. As the chapter slows, we return to the night sky, a soft glow, a drifting shadow, an ancient traveler making its way through the cosmic dark. Somewhere in that vast silence, an answer waits. But so does another question, lingering just beyond reach, carried gently on the object's faint and steady light. And in that drifting quiet, one could almost sense that something hidden is waiting to be understood. Chapter 2. Omens of Ice and Fire. Word count, 1,200. Before the sky was measured, it was watched. Long before telescopes or spectrographs, people gathered beneath open skies and read the heavens like a story painted in motion. A streak of fire over the mountains, a slow-moving glow by the moon, or a sudden burst of meteors above a sleeping village. These were not explained by gravity or orbits. They were omens, warnings, prophecies, a comet with its shimmering tail, trailing across the stars, did not just pass by. It arrived with purpose, with meaning. In ancient China, royal astronomers kept meticulous records, carving their sightings into bamboo and silk. They called comets broom stars, sweeping through the heavens to clean or punish, their long tails brushing the fate of empires. One emperor, it was said, stepped down after a particularly bright one passed, believing its message foretold his ruin. In Babylon, stargazers watched from high terraces, their eyes tracking the stars night after night. When a strange light entered the sky, they marked it on clay tablets, evidence of God speaking in fire. A bright visitor above Mars? That could mean war. A slow glow crossing the southern horizon? Famine, death, change. The Romans feared them too. In their chronicles, comets often preceded the deaths of great men. Julius Caesar's death was followed by one burning so clearly in the sky, it was interpreted as his soul ascending to join the gods. Later poets would describe it as a cosmic torch, lit by grief and carried on celestial wind. And in Europe's Middle Ages, the panic deepened. A comet wasn't just a warning, it was a curse. Villagers huddled in candlelight as bright lights passed overhead. Illness, crop failure, invasion all were tied to a fiery tail blazing across the night. These stories, drawn from firelight and fear, shaped centuries of belief. But underneath them, something else quietly formed. Observation. Patterns, memory. Even in the fear, people began to notice repetition. The same paths, the same directions, the same intervals. Something deeper than myth began to whisper through the Thales an early sense of orbit, though the word had yet to be born. In 1066, as the Normans prepared to invade England, Halley's comet appeared in the sky, so vivid it was stitched into the Bayeux tapestry, a glowing trail above the watching soldiers. No one yet knew it would return, that it had been seen before and would be seen again. The comet was still an omen. But now, it was also a recorded one, and that shift from mystery to memory is what would eventually lead to science. The soft glow of firelight gave way to the glass lens of the telescope. The whisper of crowds was replaced by the click of shutters, the scribble of notes. But even as astronomy advanced, the emotional pull of comets remained. The old stories lingered. In the margins of the star charts, Galileo and Kepler, Newton and Halley each saw not just light, but law in the sky. That these drifting shadows were not random signs, but travelers on calculable paths. They were not gods or curses, but icy bodies falling through gravities. Great web, pulled like beads on a string by the sun's invisible thread. Still, even as logic replaced lore, the wonder did not fade. To this day, a comet with a bright tail still silences a crowd. It still pulls eyes upward. It still feels like a message. And sometimes, that feeling is right. Because comets are messengers from the edge of the solar system, from the Oort cloud, from times before Earth had oceans. Their ice carries the memory of the early universe. Their orbits are clues. Their patterns are data. Yet, even now, not all patterns are understood. 31ATLAS is one such visitor. And while we no longer call it a harbinger of war or plague, we do notice that it doesn't behave exactly like it should. Its glow lingers too long. Its motion wobbles just enough to make models hesitate. Its light contains something we can't quite explain. And that old, ancient feeling returns not panic but pause. A hush, deep and wide. Modern science explains the tail, solar wind. It explains the orbit, gravity, slingshot curves. It explains the glow, sublimating ice, turning to gas in sunlight. But what if it also hides a whisper? Not from a god or ghost, but from the unknown, a hidden force, a remnant from another system. a gentle anomaly that makes even seasoned scientists lean closer. Because even now, a bright comet is still an event. It still carries with it the weight of time, the memory of impact. Comets have struck Earth before. They've carved oceans, seeded clouds, perhaps even carried the molecules that became life. They're not just beautiful. They are important. And when one behaves oddly, it doesn't just raise curiosity. It reawakens something deeper. The crackle of torches, the whisper of stars, the hush of frightened crowds staring skyward, asking questions no one could answer then, and only part me now. The watchers may no longer fear a comet's tail, but they respect its story. And with each new arrival from the dark, that story grows. Now, when a glowing traveler appears, astronomers no longer prepare rituals. They prepare algorithms. They open observatories. They call colleagues in the night. But even in that quiet data stream, the human part lingers. What if this one is different? What if this one means something? We no longer live by prophecy, but we still live by questions. And sometimes, the sky answers them not with clarity, but with wonder. Tonight, another glowing visitor moves through the sky. Not fast, not loud, just steady and strange. And in the drifting quiet, one could almost sense that another secret was about to reveal itself. Chapter 3. When the first strangers arrived. Word count, 1300. The solar system once felt like a sealed room. For centuries, it was imagined as a quiet, self-contained system. The sun at the center, the planets revolving in their predictable paths. Comets from time to time visiting like dusty letters from the edge, but all of it still belonging to us. A family of celestial bodies, bound together by the sun's gravity and lit by its ancient glow. Then, the strangers came. The first arrived in late 2017. A thin object, long and tumbling, entered the solar system from above an angle no local comet or asteroid had taken. It moved fast, much too fast to be captured by the sun's gravity. Instead, it passed through, unbothered, unbound. It was named Amamo, a Hawaiian word meaning scout or messenger from afar. At first, astronomers weren't sure what it was. It didn't glow like a comet. It didn't look like a normal asteroid. Its shape, longer than it was wide, by a factor of at least 5 to 10, defied what we expected from natural formation. It spun oddly, accelerated faintly, then faded from sight, its path bending only slightly before it disappeared into the dark again. No photograph ever captured its exact shape. Just dots, just data, just a flicker of reflected sunlight fading over days. And yet, from that flicker came something new. Confirmation that interstellar objects do visit us. Before Amua, there were theories. Of course, simulations suggesting that rogue rocks from other star systems might occasionally pass through our own, but it had never been confirmed. It was a possibility with no face. Now, it had one. Or at least, the shadow of one. The sealed room had a door. And it had opened. Less than 2 years later, that door opened again. In 2019, a second interstellar visitor entered 2I Borisov, this one unmistakably a comet. It had a glowing coma, a shimmering tail of gas and dust, and it behaved far more like the icy travelers we were used to. But its speed, trajectory, and approach all confirmed. This object, too, came from beyond the solar system. Unlike Amhamo, Borisov was easier to study. It stayed bright longer. It had a more predictable path. Its materials, mostly carbon monoxide and cyanide, gave scientists insight into the chemistry of other planetary systems. Yet even in its familiarity, it brought a quiet awe. Here was matter from another sun, older and colder, carried through space for perhaps millions of years. From these two travelers, astronomers learned a great deal. They learned how to detect the velocity differences that mark an object as foreign. They learned how to look for signs of gravitational acceleration or a lack of it. They learned that the space between stars may be far less empty than we imagined. And they learned something else. These objects are not as rare as once believed. We had simply not been watching closely enough. Now, telescopes across the world and above it are tuned not just to planets and moons, but to the quiet anomalies that pass through the dark unnoticed by most. Each observatory becomes a sentinel. Each dataset a net cast into cosmic silence. When 3i Atlas appeared, it joined a very short list. Its path, too, was interstellar. Its speed, unbound. Its approach, oddly angled. But it brought with it differences, peculiarities in its glow, its motion, its chemical makeup. These details, small but insistent, pulled researchers in deeper. Some began to whisper about patterns. 1 object was chance. 2, coincidence. 3, a pattern forming in the dark. In control rooms, under the hum of servers, and the faint clicking of keyboards, data was gathered and layered. Each frame of observation stacked like a brushstroke on a canvas too large to see all at once. Scientists mapped orbits, ran simulations, adjusted for solar wind and gravitational tides. The glow of screens revealed curves and angles, not just where 3i Atlas had been, but where it might go and where it might have come from. It had no parent star that we could trace. No debris field it followed. It was simply there, drifting, a soft anomaly cloaked in a luminous haze. And though it seemed quiet, its presence said something loud. The solar system is not a sealed vault, it is a corridor, and the locks are long gone. The sky is now a hallway. Objects come and go. Some we notice, most we miss. We are still learning how to tell which is which. Astronomers use trajectory to determine an object's origin, specifically its eccentricity. An object with an eccentricity of exactly 1 travels in a perfect parabola, just enough speed to escape the sun's pull without returning. Anything above 1 means it's not from here. It will pass through, curve slightly, and then continue into the stars. They use velocity vectors, direction and speed to watch for unnatural curves or sharp entries. They use spectrographs to split the light and search for molecules, ice, gas, rock, metal, organics. And in the spaces between, they look for what doesn't make sense. What if a visitor slows slightly at perihelion? What if its brightness flares in odd rhythms? What if its core reflects light inconsistently? These are not signs of doom. They are questions. Each one like a soft knock at the door of what we think we know. The first strangers have arrived. We met them quietly, with data and caution. And now we wait for more. Will the 4th object appear next year? In 10 years? Or is it already on its way? Dim and unnoticed. The night sky stretches in all directions. Every telescope is a lantern, held high in the dark. And in that wide silence, we are listening not for noise, but for patterns. For arrivals, for travelers. And maybe, one day, for something that is no longer just passing through. The glow faded into the horizon, but in its fading, it carried a question that lingered in every watcher's mind. Chapter 4. Plotting a Stranger's Path. Word count 1250. In the quiet glow of a dimly lit observatory, a screen flickers with lines of white and green. Curves sweep gently across a digital canvas, each one a planet, each loop a fingerprint of gravity. Jupiter arcs in bold elegance. Saturn tilts just slightly, its orbit a soft ellipse around a shared star. Between them, an odd line cuts across. The order sharp, slanted, unfamiliar. It is the path of 3IATLA. Hence, unlike the graceful spirals of planets bound to the sun, this line does not loop back. it does not settle into rhythm. It pierces the solar system like a diagonal scar, slicing across familiar gravity wells and stable orbits with the calm defiance of an outsider. Astronomers begin with what they know. They study orbit, the invisible tether between object and star. For comets born in our own system, their paths are long and stretched, but ultimately curved inward. Even those that reach the far edges of the Oort cloud are still bound to the sun, pulled gently back after thousands of years. But interstellar objects move differently. They arrive too fast. Their eccentricity, the measure of how circular or stretched an orbit is, rises above one. That tells us one thing with certainty: this object is just visiting. And that is where the mystery begins. To track 3IATLAS, scientists plot its trajectory using thousands of observations. Each point of light captured by a telescope becomes a data mark. The object's position is logged, its movement compared over time. A software model generates predictions, then refines them. Over hours and days, the curve of its path sharpens into clarity, but not too much clarity. Unlike other comets, the data around 3I Atlas refuses to settle. The trajectory wobbles, ever so slightly. Models from NASA's Jet Propulsion Laboratory show a path that differs just enough from other global observatories. One prediction bends inward more than expected. Another flattens the curve entirely. To the public, these differences are too small to notice, but to scientists, they matter. They suggest a hidden force or an unaccounted-for variable. Perhaps it's the solar wind streams of charged particles flowing from the sun, invisible but powerful. These winds push against the comet's coma, shaping its tail, altering its path by microscopic degrees. If the object is unusually light, or if its materials react differently to heat, even that gentle wind could shift its motion. Or perhaps it is outgassing, a comet's inner ice is sublimating into vapor as it warms. These tiny jets can act like thrusters, pushing the object off course. But if that were the case, scientists expect to see visible outbursts. With 3I Atlas, the glow remains steady. The haze gentle, the movement strange but smooth. And so, questions grow. Is the object shedding material we cannot see? Is it spinning in a way that alters its momentum subtly, like a slow spiral? Or is it interacting with something we do not yet understand? On chalkboards and computer screens, the solar system is redrawn with each new observation. Lines appear in bright colors: blue for Earth, yellow for Mars, orange for Jupiter. Then comes the streak of 3I race dull is spoiled, angular, alien. Its inclination is unusually steep, meaning it slices through the flat plane where most planets orbit. It arrives not from the direction of familiar comets or known clusters, but from an angle that defies expected patterns. The direction points to no parent system, no star that we can trace back along its route. It is as if the object was launched, not simply drifting. And that idea quietly, cautiously enters the minds of those tracking it. Could this be intentional? Could the trajectory be the message? In some corners of the scientific community, these ideas are quickly dismissed as fanciful. But even the skeptics watch the data carefully. They adjust for radiation pressure. They factor in planetary perturbations. They calculate how close 3I Atlas will come to Earth, to Jupiter, to the edge of the sun's influence. And yet, their answers differ by just enough to keep doubt alive. The starlight reveals more than position. It reveals composition. When light bounces off the object and into a telescope spectrograph, it splits into bands of color. These bands act like barcodes, revealing the elements present on the surface. Water ice shows up in the infrared, carbon compounds in ultraviolet. But 3I Atlas offers no clear match. Its light reflects like a stone with something added. a brightness that flickers faintly between wavelengths, not wild, just odd. And in astronomy, odd means keep watching. So the models continue. Each night, new coordinates are entered. Each hour, new simulations run. Some predictions show the object passing harmlessly through. Others place it slightly closer to a gravitational pinch point between Earth and Jupiter, or brushing the orbital edge of Mars. Still harmless, but strange, because unlike Oumuamua, which tumbled erratically, and unlike Borisov, which left a clear tail, 31Datalis moves with a steadiness that feels neither wild nor expected. It simply cuts through space, luminous and quiet. And as its arc sharpens, its behavior pushes on the edge of what models were built to predict. This is where science meets patience. Every anomaly in its path is questioned, tested, debated. And yet the answers remain slippery, like trying to trace smoke in starlight. One astronomer writes in a quiet report, "There may be a repeating curve beneath the motion, not gravitational, not random. Something else." They do not speculate further. They simply run the numbers again. In that way, space becomes a conversation. The object speaks in motion. We answer with math. The trajectory becomes the language. And somewhere between the prediction and the deviation, a whisper remains. Perhaps it is a coincidence. Perhaps it is a force we've yet to name. Or perhaps the object carries something in its silence. And so, we follow the arc not to predict impact or risk, but to listen. To hear what a stranger's path might be trying to say. To trace the sharp curve it carves through a familiar sky. And in the drifting quiet, one could almost sense that another secret was about to reveal itself. Chapter 5. Inside the Luminous Haze. Word count 1250. It begins not with fire or motion, but with glow. A soft bluish shimmer suspended in the dark, barely moving, barely changing, yet impossible to ignore. This is the coma of 3IATLAS, a hazy, luminous envelope of gas and dust that surrounds the object's core, glowing like a gentle lantern against the endless night. It is here that science meets wonder. Most comets born in our solar system carry this glowing veil when they approach the sun. Ice heats up, sublimates into vapor, and drags dust outward, forming a soft cloud. But when astronomers turn their instruments toward 3IATLAs, the veil is different. The colors are all faint greens tinged with cobalt blue, a veil that doesn't diffuse as evenly as expected. And at its center, something darker remains hidden. The nucleus does not reflect light like ice or porous rock. It swallows it, dimly, quietly. Telescopes point and track. Spectrographs split the light. And inside those spectral lines, each one a whisper from the object's skin, researchers begin to frown. They expect water ice, carbon dioxide, maybe, methane or ammonia. Instead, some of the emission lines don't fit. There are shifts, small, subtle distortions in the wavelength, like fingerprints in fog. A typical comet emits a known profile. The molecules fluoresce in ultraviolet. Gases like CNC and CO leave clean, predictable lines. But here, those lines seem overlaid with something else. Not an absence of known molecules, but the presence of unknown ones, at least, in combinations that don't match familiar databases. Some call it contamination from interstellar dust. Others say it's just a cold mix of exotic ices, unseen in most solar system comets. But a few wonder, what if this pattern isn't random? What if it's not just haze, but a code? We move through the data slowly, as though walking through mist. No sudden jolts, no loud declarations, only the silent comparison of color gradients, the gentle pulse of graphs under low monitor light, the hush of teams reviewing models in the early hours. What makes the Coma 3 IATLA so different isn't only its shape or color, it's its stability. Typical comets flare and dim. They sputter, erupt, then settle. This one doesn't. Its glow pulses evenly, like a heartbeat, soft, cyclical, timed. Could it be rotation? A slow spin revealing different materials at regular intervals? Perhaps, but the core's brightness doesn't fluctuate the way it should if that were the case. And so, attention turns outward from the visible light to radio frequencies. Radio telescopes begin listening. They sweep across frequencies in long arcs, collecting not sounds, but data rhythms, electromagnetic pulses that could, in theory, carry structure. So far, there is no clear signal that something faint and periodic appears at the edge of detection. It's not strong enough to confirm, not erratic enough to dismiss. Like a voice too quiet to hear, but too consistent to ignore. One researcher, typing at 3 a.m., writes in a log, it feels deliberate, not mechanical, not noise, like a memory that almost forms. Perhaps the doomsday signal isn't sound at all. Perhaps it's this, a pulse in the glow, a rhythm in the dust, a geometry in the gas envelope so precise that it mirrors something designed. And yet nothing confirms it. Nothing disproves it. It simply remains. The veil of 3 IATLAs, when seen in motion, behaves with eerie precision. Time-lapse imaging reveals the haze doesn't expand randomly. Instead, it pulses in ring circular waves emanating from the core, not unlike ripples on a still pond. Perfectly centered, perfectly spaced. No comet has ever shown this behavior so clearly. Some suggest internal pressure. Others wonder about layered ices melting at specific thresholds. But then there's the matter of the ultraviolet diapazone, where emissions drop sharply, almost like a shadow. Not from obstruction, but absorption. As if the veil hides something darker beneath it. An engineered core? No one says it aloud, but the thought lingers. Not because it seems likely, but because nature usually doesn't repeat patterns this precise. And when it does, those patterns come from things like crystals or organisms, not from comets. Still, the object makes no move. It drifts, it glows. It breathes gently in the dark, as if content to be watched, but not known. And so the instruments keep watching. From Hawaii to Chile, from orbiting satellites to mountaintop domes, the Coma is examined across the spectrum: infrared, optical, radio, X-ray. And always, that same lingering oddity remains. Nothing dangerous. Nothing obvious. Just enough to keep everyone asking, is this what a message might look like if it didn't want to be heard in sound? Perhaps we've been listening for tones when we should have been watching for geometry. Perhaps the doomsday signal is not a warning, but a map. Not a voice, but a pattern shimmering, steady, glowing. And perhaps, like fog hiding the shape of a mountain, the Coma is not the mystery, but the curtain over it. As we drift through this veil, the data does not shout. It whispers, it waits. And in the waiting, our eyes adjust. It is here, inside the luminous haze, that the line between science and awe becomes soft, where ice becomes story, where light becomes question. And as the glow continues, wrapping itself like a soft veil around something darker still, the silence. Deepened yet hidden in that silence was something waiting to be understood. Chapter 6. Signals in the Static. Word count, 1,300. In a silent field far from city lights, a radio dish tilts toward the night sky. Its white surface glows faintly under moonlight, like a giant ear listening for something delicate, something almost too soft to exist. Around it, rows of electronics hum in steady rhythm. Cooling fans whisper. Cables pulse with faint currents. Data flows like water. Inside the control room, monitors display nothing dramatic, just lines, curves, and numbers scrolling across black screens. To most people, they look meaningless. But to the scientists watching, each pixel might hide a cosmic whisper, a message carried across light years. For decades, radio astronomers have listened to the universe for narrow-band signals. Those thin, specific frequencies that nature rarely produces on its own. They search for repeating pulses or sudden bursts that stand out against the background static of the cosmos. A pulsar spinning like a cosmic lighthouse, a flare from a galaxy cluster, the echo of a supernova's collapsing core, or, in dreams, too fragile to voice aloud a sign of someone else. But most of the time, the universe speaks in noise. Gentle, endless noise. A radio telescope hears the crackle of the sun's corona, the faint hiss of distant nebulae, the low hum of cosmic microwave background, the afterglow of the Big Bang. Add to that the interference from Earth. Airplanes, phones, satellites, microwaves, thunderstorms, passing cars, distant power lines. So, researchers write code filters to sift the human-made from the natural, the expected from the unexplained. Lines and lines of algorithms, each one designed to catch something unusual hidden in the static. False alarms happen often. A famous signal once turned out to be a microwave oven opening in the staff lounge. Another rhythmic pulse came from a nearby electric fence. At one observatory, a repeating tone believed to be extraterrestrial intelligence was eventually traced to a faulty cable. Signals rise, fall, and vanish like fleeting dreams. Most are forgotten. Some are debated for years. But all of them teach scientists how to listen better. And now, as 3IATLS drifts closer to the inner solar system, those listening tools turn toward it, not because anyone expects a call, but because its arrival feels strangely timed. Its trajectory is odd. Its haze puzzling. Its chemistry uncertain. And its stability almost unnervingly quiet. So researchers begin to ask, what if this visitor carries not a sound, but a pattern? Not a transmission, but a rhythm woven into its orbit or its glow. Nothing about the object screams danger, but nothing about it fits the mold of a typical comet either. And so, the listening begins. In New Mexico, dishes pivot together, moving as if breathing. In Australia, wide arrays sweep the sky with electronic precision. Across the ocean, small. Amateur telescopes join the effort, people at home letting their instruments capture time-lapse exposures, hoping to record the faintest anomaly. The universe remains calm, the static, uniform. Then, late one night, a faint spike appears in a narrow band of frequencies. Tiny, barely rising above the noise. It lasts for 3 seconds, then vanishes. To the untrained eye, it looks like nothing. But those 3 seconds trigger 3 hours of debate. Many argue it's interference, maybe a passing satellite or a distant radar sweep. Others think it might be thermal noise. A handful of researchers circle it in silence, zooming in on the graph again and again. Because the signal slope its rising and falling curve matches the motion of 3I Atlas at that exact moment. Not proof. Not even strong evidence, but enough to keep them awake. More data is collected. More filters are run. And as the hours pass, no repeat signal appears. Just quiet. Quiet, and the flickering numbers on screens. Still, the question lingers. If an object wanted to send a message, one not heard as sound but seen as math, what would it look like? A repeating pulse? An unexpected brightening? A wobble in trajectory? A subtle shift in ultraviolet emissions? 31ATLS has all of these, but not in ways easy to interpret. They could be chance, they could be natural, or they could be something deliberate, dressed in the language of comets and dust so deeply that no one recognizes it. Scientists remind, themselves of bias. Humans love patterns. We see faces in trees, voices in wind, meaning in shadows. It's natural to imagine intelligence where there is none. But still, the timing feels unusual. Amur, Borisov, now 3I Atlas. 3 strangers in a decade, after centuries with none. Coincidence? Or a message written not in voice, but in presence? The narrator leans back into calm explanation. Radio. Waves travel through space with almost no loss. If a civilization wanted to broadcast widely, they might use radio bands nature rarely touches. But if they wanted secrecy, they might hide a message in the glow of a comet, or in the pattern of a trajectory, or in something we haven't learned to read yet. One astronomer writes in a private note, "We're expecting noise, so we hear noise. But what if we're meant to see, not hear?" It's not fear driving the questions. It's curiosity. A quiet, steady pulling at the edges of understanding. A soft hope that the universe still holds surprises. As 3I Atlas continues inward, the radio dishes keep turning slow, patient, unwavering. Their metal surfaces catch moonlight like giant petals of a steel flower, opening toward the stars. No new signals appear that night. No bursts. No repeats. Just the steady heartbeat of the cosmos, ancient and unbroken. Yet something about the silence feels heavier. Not threatening, not comforting. Just full like a breath held too long. The glow faded into the horizon, but in its fading, it carried a question that lingered in every watcher's mind. Chapter 7. Inside NASA's quiet rooms. Word count 1,200. Not all moments of tension happen in chaos. Some unfold in silence. Inside NASA's mission analysis rooms, the atmosphere is still. A soft hum from racks of computers. A blinking LED on a coffee machine. The whisper of a chair sliding back as someone leans forward to stare more closely at a screen. It's not a scene of cinematic drama. There are no alarms, no panicked shouting. Just focused minds working under low light. This is where decisions are made, where calm replaces panic, where numbers, not noise, tell the story. 3I Atlas is being tracked, not as a threat, not as a confirmed anomaly, but as something that demands attention. It moves with a kind of quiet certainty, cutting across known orbits like an ancient traveler walking a forgotten road. To the public, it's just another strange rock passing through. To the people in these quiet rooms, it's a question. Some call it a comet. Others aren't so sure. They look at the orbit, the curve that dips and twists through the solar system, like a signature that no one recognizes. They consider the way it reflects light, the way its tail behaves, the way its path defies easy modeling. And so the risk teams go to work. They begin with probabilities. Impact probability isn't just a simple yes or no. It's built from layers of data: trajectory, velocity, gravitational interactions, observational error margins. They measure it in terms of low likelihood, high consequence, events that are extremely rare but potentially devastating. Even if the odds are 1 in a billion, it still earns attention. That's the rule. Not because panic is needed, but because preparation is part of the promise. Behind one screen, an analyst simulates orbital deviations. What if the sun's gravity tugs slightly more? What if there's an outburst of gas near perihelion? Each simulation spins a new future across the digital solar map. Most are uneventful, but one or two, they raise eyebrows. A pass close to Mars, a gentle gravitational slingshot near Jupiter, a shift so slight it could go unnoticed until it's already happened. No one jumps to conclusions. Instead, they refine the models. They bring in higher resolution data from ground-based observatories. They cross-check with international partners. ESA, JAXA, the Canadian Space Agency, all watching. all listening. Some models suggest a deeper strangeness. The object's trajectory isn't just unusual. It may be influencing nearby objects in tiny, measurable ways. Not enough to cause alarm, but enough to raise quiet concern. It's not about fear. It's about control. In these rooms, what matters most is knowing, understanding the threat, however small. Being able to answer the question, are we prepared? Because unlike hurricanes or earthquakes, space doesn't knock before it enters. It moves silently, predictably until it doesn't. And so for the team, 3-1, ATLAS is treated with the same respect as any other cosmic guest. Simulations are labeled and archived. Meeting notes are written in calm, precise language. The object remains consistent with a hyperbolic orbit. No deviation beyond model tolerances. Unexplained spectral lines noted further study required. No panic, but no dismissal either. Some scientists, more philosophical than others, sit quietly with their coffee, staring at plots and thinking about meaning. They wonder aloud, is it just a comet? Is it just data? Or is this something else entirely? One scientist writes in her notebook, even if it's natural, why does it feel like a signal? She doesn't mean it literally. She means it emotionally. There's something about the timing. Something about how it follows Oumuamua and Borisov. Something about how it seems to arrive with a kind of cosmic poise. Not too early, not too late. Just now. Another scientist, more pragmatic, reminds her, feelings are not data. But even he continues watching the graphs a little longer than usual. The room is filled not just with people and screens, but with something softer. Responsibility. A quiet weight that comes from knowing the world does not watch them every day, but will the moment they say something is wrong. So they don't speak until they're certain. They keep testing, keep checking, keep listening. Because to them, 3-IATLS is not a monster in the sky. It's a visitor. And visitors can carry meaning, even if they don't mean to. One engineer looks over a new set of data and whispers, it's like it knows how not to cross a line. That line? Earth's orbit. Not breached. Not even. Approached closely. Still, they monitor. Because anomalies don't always announce themselves with noise. Sometimes they whisper. Sometimes they glide. And sometimes they remind us of how little we truly control. We can map the stars. We can land probes on comets. We can walk on the moon and speak to robots on Mars. But we cannot stop an object like 3-IATLAS if it chooses to fall. We can only see it, track it, model it, and hope that we're right. So in the quiet rooms of NASA, hope and calculation live side by side. One in the equations, the other in the eyes watching them. And as the glow of 3-IATLAS shifts slowly on distant screens, the silence deepened yet hidden in that silence was something waiting to be understood. Chapter 8. Futures written in orbits. Word count 1300. In the stillness of deep space, futures unfolding curves. Every comet, every asteroid, every silent traveler is guided by invisible lines paths, drawn by gravity, mass, and momentum. They bend gently around planets, weave through the asteroid belt, or plunge into distant darkness. These paths are not just trails. They are stories waiting to be read. And 3-IATLAS has now written its own. We begin not with alarm, but with possibility. In one version of the future, 3-IATLAS passes us harmlessly, a drifting shadow that never comes close enough to matter. It leaves behind no scars, no interference, only data, only wonder, only memory. Telescopes archive the images. Spectrographs archive the light. Its tail is folded into research papers and quiet lectures. The story ends peacefully, like a leaf, brushing past a sleeping pond. But space is never still. And not all futures are quiet. In another version, nothing crashes. Nothing breaks, but something shifts. Because even a small body just a few kilometers wide can ripple across the solar system's balance if its trajectory is just right. Or just wrong. Imagine 3I Atlas passing near a dormant object, an old asteroid, long catalogued and barely moving, resting in the outer asteroid belt. Its orbit is stable, circular, predictable. But now, a nudge, a subtle gravitational handshake. No impact, no flash, just a tilt. That asteroid begins to drift. Not wildly, just slightly. Its next pass by Jupiter is a little closer. Its next orbit a little longer. And decades, maybe centuries later, it intersects with something it was never meant. TO. A small change, a delayed consequence, a cosmic domino. In this version, 3I Atlas becomes the first whisper in a long echo chain. And that's how space works, not with sharp jolts, but with slow, patient rearrangement. The solar system is a dance. Every object knows its rhythm. But when something new enters the floor, even briefly, the choreography shifts. Gravity becomes a messenger. It carries force without sound. It speaks not in push or pull, but in persuasion, gently leaning one object toward another, slowly bending arcs into spirals, ellipses into parabolas. Even the moon was once flung from Earth billions of years ago by the fury of a collision and the poetry of gravity. And still today, it drifts farther from us about 1 inch per year. Small shifts become legends, written in dust and time. This is why NASA cares, why observatories watch, why data models run thousands of simulations. Not to predict disaster, but to explore possibility. Because possibility in space is everything. In one model, 3I Atlas crosses a region of gravitational resonance. It doesn't cause a threat directly, but it stirs up a trail of icy bodies, centaurs, trans-Neptunian objects, even fragments in the scattered disk. Some of these begin new journeys. One takes a path inward, slow and curling. 2 centuries from now, it swings past Saturn, then brushes Earth's orbit. Again, not impact, just potential. This is the delicate nature of the cosmos. No alarms, just probability. And NASA has a name for this kind of risk. Low likelihood, high consequence. Like a match dropped in a dry forest. Most of the time, nothing happens, but sometimes the spark takes root. Yet even among these simulations, the tone is never fear. It is responsibility. To know, to track, to model. In the rooms where futures are calculated, scientists speak softly, not because they are afraid, but because the scale humbles them. One researcher gestures to a holographic model, a 3D map of orbits and trajectories. Everything is so close, she says, and yet so impossibly distant. Lines crisscross, the void like silk threads. A single object nudged slightly could change the weave. And it doesn't take an impact to matter. 3I Atlas is not large. It's not fast enough to escape notice. But it may be timed just right to brush against stability itself. And so, every night, more simulations run. Each begins with real data: mass, velocity, spin, position. Then they shift one variable by a fraction less than a heartbeat. Then they wait and watch. Most paths loop safely outward. Some cross nothing at all. But a few show future intersections, tiny, late, and almost untraceable. Those are the ones scientists watch most closely. Not because they believe disaster is coming, but because they know it sometimes walks in slow circles. And even then, 3i Atlas may be nothing more than a messenger, a harbinger not of doom, but of mystery, a traveler reminding us that orbits are not promises. They're agreements held together by gravity and silence. Still, the question lingers. What is the object really doing here? If it's just rock and ice, its presence is a coincidence. If it's something more engineered, intentional, observed, then perhaps these orbital features are not accidental. Could it be showing us how fragile the system is? Could its path be a diagram? Could it be a signal not to destroy, but to reveal? Even the word doomsday is less about destruction and more about reckoning, about awareness. And awareness changes. US, because even if 3IATLS never touches a thing, it will have touched us. Our curiosity, our caution, our belief in what's possible. And that is what scientists fear most, not the object, but the unknown it carries. A future not yet written, an outcome not yet shaped, a system so vast that even the smallest actor may become a note in its quiet, ancient song. As we drift along Earth's own orbit, circling the sun in patient rhythm, we look up and wonder, what have comets done before? What stories do they still carry in their cores? And what new tale does this one begin? Because the glow faded into the horizon, but in its fading, it carried a question that lingered in every watcher's mind. Chapter 9. The comets that made and scarred us. Word count, 1250. Beneath the stillness of night, Earth spins gently, an ancient planet wrapped in oceans and atmosphere, carrying the memory of every shadow that's ever passed through its sky, long before cities, before continents looked as they do now, before even the moon found its home in our orbit. There were comets. They came not as monsters, but as messengers. Some brought destruction, others brought gifts. Both left fingerprints in the stone. When we speak of comets, we often think of their light glowing tails sweeping across the stars like celestial paintbrushes. But their story begins long before that glow ever touches the eye. Billions of years ago, when the Earth was still molten, and the sky filled with the debris of a newborn solar system, icy bodies from its outer edges began to fall inward. These were the comet's fragments of water, rock, and frozen gases born in cold darkness. Drawn toward the sun by gravity's slow persuasion, they struck the Earth again and again. To the ancient crust, they brought chaos. To the oceans that didn't yet exist, they brought water. It is one of the great theories of planetary science that Earth's water, its oceans, its rain, even the molecules that fill every cell may have come, in part, from comets. From ice hurled at us from the farthest reaches. From collisions that vaporized instantly, only to cool again and settle, drop by drop, shaping the planet we now know. And not just water. Inside the cores of certain comets, scientists have found organic molecules, the precursors of life. Amino acids, simple sugars, even components of RNA. On Earth, these molecules would become the first sparks of biology, but their arrival may have come on the back of destruction, because comets don't tap gently. They arrive at tens of thousands of miles per hour, and when they hit, they reshape entire regions. We see the evidence in ancient scars. The Chicxulub crater, buried beneath the Gulf of Mexico, its circular outline marking the impact that ended the age of dinosaurs. The Vredefort Dome in South Africa, one of the oldest known impact sites, nearly 2 billion years old. The Tunguska event over Siberia, 1908, not a crater, but a massive blast that flattened 800 square miles of forest. Comets have scarred Earth, but they may have also made it possible. Possible for water, possible for life, possible for us. They are both bringers of beginnings and agents of endings. And that duality, the grace and the danger, is what gives them their quiet power. When a comet enters our skies, even now, we feel something old stir inside us, a mix of awe and unease, a recognition that these luminous visitors shaped the world before we could name them. From ancient China to the Mayan codices, from Egyptian scrolls to medieval European records, comets were always recorded with reverence and fear. Not because they were always destructive, but because they reminded us how small and fragile we are. That same feeling returns when an interstellar object like 3-IRA-TLAS enters our awareness. It's not fear of impact. It's the weight of possibility. That even now, in a world of satellites and simulations, something from beyond can arrive and shake our certainty. It's why scientists continue to search cometary ice for complex molecules. Why they land probes on comet surfaces, like ESA's Rosetta mission did with Comet 67P. Why they chase every unusual trajectory, every unexplained emission, every pulse of ultraviolet light. Because every comet carries more than dust. It carries history, and sometimes it carries memory. Imagine a comet, frozen and silent, drifts for 1 billion years through interstellar dark. It passes dying stars. It slides past nebulae. It collects radiation, dust, and quiet damage. Then, for reasons unknown, it falls inward toward our sun, toward us. Inside it may be molecules untouched since the universe was young. Inside it may be clues to what we once were, or what we might become. This is why a visitor like 3-ITLAS matters. Even if it never touches Earth, even if it passes quietly by, its presence stirs something deep in awareness that we are part of a wider story, that the forces which built us are still out there, drifting. And just as comets may have helped begin our story, it's fair to wonder, could one ever help write its end? Not through fire, necessarily. Not through impact or devastation, but through reminder. A reminder that Earth's balance, its oceans, its life, its blue calm in a sea of black is not guaranteed. It is, though. Result of timing, of motion, of millions of near misses and just right alignments. And it only takes one outlier, one forgotten comet, one drifting anomaly to change the rhythm. But perhaps not to end it, perhaps only to wake us. Because maybe the greatest message comets carry is not fear, but humility. That we exist not apart from the cosmos, but inside it. Carved from its collisions, cradled by its gravity, shaped by its shadows. So when you next look up and see a streak of light across the night, know that it may be ancient, older than any mountain, older than our moon, a fragment of what once was, returning with no reason except that motion brought it here again. And in the drifting quiet, one could almost sense that another secret was about to reveal itself. Chapter 10. The Night Watchers of the Sky. Word count 1250. Somewhere, under a dark sky untouched by city light, someone is looking up. Not just tonight, and not just now, but always through centuries, across continents, under stars that rise and fall like slow breaths over generations. Watching the sky is not a new act. It is one of the oldest. Thousands of years ago, a man or woman might have stood barefoot on warm stone, scanning the heavens not for answers, but for patterns. The moon rising late, a wandering star, a planet shifting ever so slightly each night. A sudden streak of fire tracing the dome above, too quick to hold, too bright to forget. They watched with nothing but their eyes and memory. No telescopes, no sensors. Just the rhythm of the cosmos imprinted in their minds like tides pressed into sand. In Babylon, sky priests tracked Venus with clay tablets. In ancient China, astronomers carved comet sightings into bone. In Egypt, pyramids were aligned to the stars. And in the Maya world, eclipses were foretold with frightening accuracy. To watch the sky was to understand time. To understand time was to feel power. And to feel power was to feel responsibility. That sense never left us. Today, the watchers wear lab coats and headsets. They operate instruments that peer deeper than any human eye could imagine. Instead of rooftops, they sit in observatories high in the mountains or miles underground, or in orbit itself. But the heart of it remains the same. Look up and learn. We now map the sky with mathematical precision. Automated surveys like Pan-STARRS, Linear, and Atlas scan the heavens nightly, sweeping large sections of space in search of moving points. These systems detect asteroids, comets, even unknown interstellar objects like 31ATLS, adding each to a growing catalog that now numbers in the millions. Click. Another image. Click. Another sweep. Each frame contains dozens, sometimes hundreds of stars. But somewhere in that image is a dot that wasn't there the night before. That dot becomes a number. That number becomes a name. That name becomes a line in a vast database. 31ATLS is just one of those lines. But in minds like yours and mine, it glows brighter. Why? Because of its timing, its strangeness, its silence. Because even among millions of objects, some arrive with a presence you can feel. Still, most of the watchers never see the sky themselves. They sit behind screens, thousands of miles from the telescope's lens. A researcher in Hawaii collaborates with one in South Africa. A radio signal from Chile arrives in Spain. A faint light observed from Arizona is confirmed by a team in Australia just hours later. This global web of vigilance is fragile, yet vast. No one person watches the whole sky, but together, they watch enough. Each night, data flows between observatories like a quiet river. Predictions are updated. Orbits are refined. Risks are recalculated. Most discoveries are uneventful. Another rock, another ice body, another past that will never matter to Earth. But still they watch. Because one day, something may matter. And the watchers will be the first to know. But not all watchers are scientists. Some are children on back porches. Some are artists sketching the moon. Some are travelers lying beside a campfire, waiting for a meteor to split the sky. And some are people like you listening in the dark, wondering what it all means. Tonight, as you lie in bed, drifting towards sleep, you join them. You become part of that lineage. A link in the chain of eyes that have traced light across the stars for thousands of years. The stars you see tonight are the same ones seen by the ancients. The same Orion, the same Ursa Major, the same gentle path of the Milky Way, like a spill of stardust across the dome. 31ATLAS may not shine brightly to the naked eye. It may never pass close enough to spark awe on sidewalks or inspire myths by firelight. But it is seen, it is remembered, it is recorded, because we are watchers. And watching the sky means more than measuring orbits or predicting collisions. It means remembering that the universe is in motion, even when our lives feel still. It means finding comfort in something eternal, and wonder in something unknown. But what happens when the sky grows quiet? When no new visitors appear? When the dots stop shifting? When
the same stars return night after night without interruption? What does it mean when silence stretches long enough to feel like absence? The glow faded into the horizon, but in its fading, it carried a question that lingered in every watcher's mind. Chapter 11. The silence between visitors. Word count, 1300. The universe has a sound, though you cannot hear it with your ears. It is the sound of silence, vast, steady, ancient. A silence so wide it could cradle 1,000 civilizations and still feel empty. After Oumuamua, Borisov, and now 3I/Atlas, that silence feels different. Not broken, just interrupted. As if something faint is tapping gently at the edges of our perception. 3 interstellar visitors in such a short span of human time create a quiet sense of pattern. Not enough for certainty. Just enough for wonder. Yet, when astronomers lift their eyes beyond our solar system, they do not see crowds of travelers. They see emptiness. They see exoplanets circling distant stars, some hot, some cold, some small, some wide, but nearly all of them quiet. No signals. No flickers of technology. No unmistakable signs of life. What they see most often is distance. Vast stretches of black between star systems, where nothing shines except old starlight and the thin glow of drifting gas. The Fermi paradox asks the question simply, if the galaxy is so full of planets, where is everyone? You could float through the Milky Way for 1 billion years and never pass another world with thought, with sound, with intention. Not because they don't exist, but because the void between stars is unforgiving. Solar systems are islands. The space between them is an ocean made of darkness. Some scientists point to hostile space, rogue radiation, death by gamma ray, solar flares that strip atmospheres, dying suns collapsing into silent embers. Others imagine civilizations that burn too brightly, too quickly, consumed by the same curiosity that built them, or lost to wars, disasters, or resource collapse. Some envision civilizations too far apart in time. One rises when another has already fallen. A cosmic relay where no two runners ever overlap. And so, the galaxy remains mostly mute. Against that mute backdrop, each interstellar visitor feels more like a deliberate knock on the door. A reminder that the silence is not absolute. That something, somewhere, may still move. 3i/Atlas is not loud. Not threatening. It slips through the solar system without fanfare. But because the universe is so deeply quiet, its presence feels amplified. A single object in a silent field. A single ripple on a still lake. A single footprint in an untouched desert. Astronomers wonder if it is coincidence. Or if the timing means more than randomness. If Oumuamua, Borisov, and 3i/Atlas are harbingers, not of doom but of awareness. Perhaps these visitors are not signals themselves, but clues, breadcrumbs scattered by the mechanics of the universe. Imagine a civilization trying to send probes, not messages. Imagine those probes failing after millennia. Imagine only fragments drifting on. We may not be seeing intention. We may be seeing debris of civilizations that lived and faded before Earth's continents formed. Or we may be seeing nature, beautiful, cold, uninterested, simply playing out its ancient motions. Either way, the silence continues. It stretches across star nurseries where new suns ignite out of nebulae, like candles blooming in slow motion. It blankets exoplanets so far away their light reaches us long after they may have changed, or died. It curls around collapsed stars, black holes that swallow not just matter, but any possibility of hearing their past. And through that silence, Earth spins quietly, one world among billions, listening for a reply that may never come. This is why visitors matter. Why they stir questions. Why they feel like cosmic whispers. Because they break the monotony. Because they remind us that space is active, not empty. Because they bring motion into stillness. Even if they are just rock and ice. When you lie outside at night, watching Orion rise or the moon cast soft shadows on the ground, it's easy to feel alone. But above you, unseen, are countless objects drifting in slow arcs. Some born here. Some born far away. Some carrying secrets older than Earth itself. And every few years, one of those secret keepers slips through our sky. Silent. Bright. Unclaimed. Is 3i/Atlas merely the third in a random sequence? A coincidence in a lonely universe? Or is it part of a hidden pattern we don't yet know how to read? A whisper in a language written not in words but in motion? Not in sound but in presence? A cosmic riddle forming at the edge of what we can perceive. Astronomers do not pretend to know the answer. They only know the silence around us is vast. And in that silence, even a single visitor can feel like meaning. The sky tonight is calm. Most stars stay where they always are. Most planets follow their assigned paths. Only a few travelers disrupt that order. And somewhere, far beyond your sight, 3i/Atlas continues on its quiet way, carrying whatever truth it holds deeper into the cradle of silence. And in the drifting quiet, one could almost sense that another secret was about to reveal itself. Chapter 12. Shadows beyond the solar system. Word count, 1200 beyond the last warm breath of the sun, past the gentle glow that touches Saturn's icy rings and the blue silence of Neptune's orbit, lies a place where maps grow dim. It's not a single destination but a frontier of distance and mystery, a realm so distant and cold that light from our star arrives only as a fading whisper. This is the domain beyond the planets, where shadows drift, ancient and unseen, across the edge of what we know. As we pass the slow orbit of Uranus and drift beyond Neptune's wide arc, the solar system begins to lose its familiar rhythm. Out here the years stretch long and quiet. Gravity still pulls, but with a softness that feels more suggestion than command. Somewhere farther still, perhaps 10 or 20 times Neptune's distance, lies the suspected hiding place of something enormous and invisible, what some call Planet 9. We've never seen this object directly. No telescope has caught its silhouette against the stars. But like detectives piecing together a case from scattered clues, astronomers have traced odd wobbles in the orbits of far-flung icy bodies. Their paths, curved just a little more than expected, suggest a hidden presence. It's as if something massive lurks beyond, tugging with unseen fingers on the edge of the solar stage. Farther still, like a vast moat around the fortress of our system, lies the Oort cloud. We've never visited this region either, not even close. It's not a place of solid planets, but a distant shell of icy fragments, comets asleep in the dark. They drift there, untouched for billions of years, like frozen memories waiting to be disturbed. Every so often, one is nudged by the gravity of a passing star or a ripple in the galactic tide. It rolls inward, spiraling slowly toward the sun, flashing into a comet's tail as it wakes. This is where visitors come from. Not from Mars or Jupiter or any place close, but from the deep cold. From the distant reservoir where time forgets and light fades. An object like 3I/Atlas, cutting across the stars with a strange path and a hidden origin, might have been born here, or even farther beyond. Some astronomers wonder whether such messengers are not random at all. Could there be patterns in how they appear? Could the timing or angle of their approach reveal something about the gravitational tides they ride? It's possible that massive, undiscovered planets or entire fields of dark matter subtly shape the trajectories of these ancient travelers, guiding them along curves we don't yet understand. Others take the question farther still. What if the very fabric of this outer realm, beyond the planets, beyond the cloud, is warped by things even stranger? Distant galaxy clusters, vast and heavy, could pull at the solar system with invisible threads. The gravitational pull of these unseen giants might slightly tilt our star's motion or bend the path of comets as they fall inward. It's like a hallway of frozen lanterns, each unlit and swaying gently, disturbed only when something much larger brushes past. And if all this, the comets, the dark planets, the rogue objects, is shaped by forces we can't see, then what does that say about the edge of our maps? Maybe the Real signal isn't a single object streaking across the sky, but the silence behind it. The space that remains uncharted. The hints of mass we haven't accounted for. The orbits that don't behave. It's as if the universe is whispering from behind a curtain we haven't yet lifted. The idea of a doomsday messenger has always haunted the minds of watchers. But what if the real revelation isn't destruction? What if it's simply incompleteness? To gaze into the far dark and realize that our diagrams are only outlines, that's the deeper shift. That's the shadow. Not an explosion or a fireball or a crash from the heavens, but the quiet realization that we don't yet know all the players in the great celestial dance. So we look outward. We study the tilt of forgotten orbits, the return of icy wanderers, the long, slow fall of objects that shouldn't be here but are. And in each faint anomaly, each unexplained tug, we feel the edge of something vast. Not frightening, not even threatening. Just waiting. And maybe that's what makes it so hard to ignore. Because in the cold quiet past the known planets, something old is drifting. Not with intention, perhaps, but with presence. It does not glow. It does not call. But it moves. And in the drifting quiet, one could almost sense that another secret was about to reveal itself. Chapter 13. The Quantum Night and Parallel Dreams. Word count, 1,300. The stars do not blink in space. They burn with quiet certainty. But here, in the dreamlike folds of the universe, certainty begins to blur. Imagine everything slowing down, your breath, your thoughts, the very fabric of time. As we drift away from the outermost edges of the solar system, we find ourselves not in another place, but in another kind of thinking. A deeper night, more fragile than any cold vacuum or spinning comet. This is the quantum night. In this world, nothing is exactly where it seems to be. A single particle might exist in many places at once, like a cloud of possibility, not a point. Electrons swirl in invisible fogs. Photons blink into and out of existence like whispers lost in wind. Here, reality is not a line but a question. A shimmering field of maybes. It sounds like poetry. But it's the language of quantum physics. A science so precise it can describe the behavior of atoms, yet so strange it feels like dreaming. One choice leads to many outcomes. One motion unfolds into a forest of futures. Physicists have called this the many-worlds interpretation. And while it began as a mathematical idea, it now touches something deeper, something human. What if every decision, every event, spawns not one path, but a branching tree? In one world you're listening to this, eyes closed, wrapped in stillness. In another, perhaps you chose a different story, a different moment, a different dream. And out there, in the vast silence between stars, what of 3i/Atlas? In this frame of possibility, the ancient traveler does not follow one fixed path. It follows all of them. In one reality, it grazes Saturn's rings before dissolving into the sun. In another, it drifts forever in darkness never seen. In yet another, it curves just so, impacting a planet, reshaping a world. And in most of them, it's nothing more than a passing shadow, a mystery, a forgotten note in a song we barely hear. This idea, the multiverse, is not about science fiction, not in this moment. It's about the limits of what we can know. If the universe branches at every quantum decision, then there are versions of you listening to this under different skies. Some before sleep, some in waking hours, some not here at all. And in each of those versions, 3i/Atlas takes a different route. You may never notice those other worlds. No machine exists that can peek through the branches. No telescope bends across universes. But the math allows it, the logic permits it, and the dream invites it. So what then of the doomsday signal? In one world perhaps it's real. In another it never happens. In a third it's misunderstood, just a comet, just a rock. And here in this one the only signal is a question. Why this world? Why this version, this moment, this path? The thought lingers like a soft glow at the edge of sleep. Because that's the heart of it, not just particles or equations but choice, consciousness. You hear now. What does it mean that in all the infinite versions of things, you ended up listening in this one? There's no answer. Only wonder. It's the same wonder that guides astronomers who look into black space and chart the paths of drifting lights. The same wonder that asks if fate is real or just the shape probability happens to take. It's the gentle question behind every story whispered under stars. What else could have been? You won't see the branches. You won't hear the split. But deep in the mathematics of the universe, reality is more like a song than a machine. A harmony of possible notes. And you, somehow, are listening to just one verse right now under this sky. So as the dream continues and the stars hold their breath, the quantum night stretches on. And in that silence, somewhere between science and sleep, a single version of a traveler passes overhead, while 1,000 others drift beyond reach. And the glow faded into the horizon, but in its fading, it carried a question that lingered in every watcher's mind. Chapter 13. The Quantum Night and Parallel Dreams. Word count, 1,300. Beneath the hush of the sleeping Earth, as the stars drift slowly overhead, the universe reveals one of its most curious truths. Reality is not as solid as it seems. In the gentle dark, where the mind loosens and the world softens, the story drifts into a more speculative realm, one painted not in facts alone but in possibilities. At the smallest scales of existence, the universe dances. Electrons do not orbit like planets but hover in clouds of maybe. Photons pass through slits they never seem to touch. Particles appear to make decisions only when watched. This is the strange territory of quantum mechanics, a quiet, humming reality that exists beneath everything we know. In this quantum night, certainty is only a shadow. Instead of answers, there are probabilities. Instead of one path, there are many. The laws that govern these hidden places are unlike anything we experience in daily life. And yet, they shape every moment, from the flicker of starlight on your wall to the path of a distant traveler from another star. Some physicists, standing at the edge of this unknowable depth, imagine a branching forest of realities. They picture the universe not as one single thread, but as a vast collection of timelines, each one born from a different outcome. In this vision, the multiverse, every possibility that could happen does happen somewhere. So let us imagine a universe not of one 3i/Atlas, but of countless versions. In one branch, the interstellar object slings through the solar system unseen, a silent messenger never caught by our telescopes. In another, it grazes a planet's edge, disturbing atmospheres and stirring radio waves. In yet another, it fractures, trailing soft light like spilled dreams. And in one distant world, perhaps it comes closer, much closer, bringing questions no one was ready to answer. Each path is its own story. Each version of reality contains a different Earth, a different night sky, a different listener. And yet, you are in this one. What does it mean that this is the world in which you listen right now to the story of 3i/Atlas? Quantum theory says nothing about fate. It says the universe offers chances, not certainties. Electrons can go here or there. Atoms can decay or not. A star can collapse or hold. It is only when we look, when we measure, when we observe, that one possibility becomes real. Until then, the world floats in a gentle veil of what if. So too, perhaps, with us. This chapter is not about fear. It is not about predicting a future of destruction or peace. Instead, it is about wonder, about what lies beneath the surface of the visible world. If the multiverse is real, then your life is a single glowing thread in a vast and hidden tapestry. Every choice, every missed moment, every strange object streaking across the stars might exist in another way, in another version of events. And still here you are, listening, breathing, alive in this one thread on this version of Earth, under this particular sky. Maybe there is comfort in knowing that the universe does not demand certainty from us. Maybe there is peace in accepting that even the stars live in possibility. Just as comets follow curved trajectories through gravitational fields, perhaps our thoughts, our fears, and our dreams follow arcs we don't yet understand. When astronomers first saw the strange blur of 3i/Atlas, they captured only a sliver of its story. They measured its motion, calculated its orbit, wondered where it had come from and where it was going. But what they could not see was what could have been. What other skies it might have passed through. What other eyes might have seen it. To drift through the cosmos, unbound and unnamed, is to exist like a quantum particle, known only when touched by attention, shaped by the act of being seen. And in some quiet corner of possibility, maybe you are the observer who changes the story. Maybe simply by listening, you pull one thread tighter, make one shadow fade, collapse one mystery into understanding. Or maybe, you are just a gentle witness to a mystery that will never fully resolve. That too is enough. As this chapter settles into quiet, let your thoughts drift like particles in a cloud of maybe. Let the world blur a little. Let the definitions soften. What matters now is not the answer but the question. If all paths are possible, what does it mean that this is the one you walk? In the soft hush between moments, in the flicker of possibility just before sleep, the silence deepens, and hidden in that silence is something waiting to be understood. Chapter 14. The listener at the window, word count, 1250, the window is slightly open. A breeze slips through, brushing the curtain just enough to make it breathe. Outside, the night has settled into its quiet rhythm, no longer the domain of busy cars or hurried voices, but of soft rustling leaves, distant streetlights, and the silent turning of stars. You stand there, maybe barefoot on a wooden floor, maybe wrapped in the last warmth of the day, and you're looking up. Not for anything in particular, just up. The city is aglow behind you, muted and humming, but above it all, the sky stretches deep and dark and forever. This is not a scientific moment. There are no calculations here, no instruments. No satellite feeds or high-resolution spectrographs. Just the eyes of one person and the ancient light of stars that left their suns before your great-grandparents were born. Somewhere out there, 3i/Atlas continues its silent journey, its orbit arcing through the deep, beyond planets and weather, beyond even time as we know it. But tonight, that's not the story. Tonight, the story is you. You scrolling past headlines. NASA decodes strange transmission. Interstellar visitor linked to possible doomsday trajectory. New alien signal confounds astronomers. Each headline louder than the last. Urgent. Crowded. Flashing in red banners and bold fonts. But you didn't click any of them. You just looked out the window instead. And in that small choice, a quiet act in a noisy world, the universe shifts. It becomes not a threat to fear, not a warning to decode, but something else. A companion. Silent. Vast. Steady. Sometimes wonder is enough. There's something fragile about this feeling. A thin thread of awareness, pulling you gently into the present. You're not solving the mystery of space tonight, not unraveling the path of an anomaly through gravity's grip. You're simply watching. Listening. Noticing how small you feel, and how that smallness doesn't feel like weakness but like calm. Because in this stillness, the sky doesn't ask anything from you. It doesn't demand answers or action. It just is. Infinite, turning slowly, always there. And that presence, unchanging yet never the same, can feel like the kindest kind of company. Astronomers speak of trajectories, of comets and radiation signatures, of anomalies blinking at the edge of detection. But sometimes what matters most is how those things make us feel. Loneliness, yes. You are one person among billions, standing at a window beneath a universe that may never know your name. But also awe. Also hope. Also a strange, delicate joy that rises not from knowledge, but from attention. Maybe this is why, in moments like this, people feel the need to share the sky. To text someone, "Go look at the moon." To post, "Anyone else see that light?" To whisper to a child, "That star right there, it might not even exist anymore." Because wonder, like starlight, seems to need space to travel. And perhaps that is the real message of 3i/Atlas. Not survival through space, but survival through compassion. Through memory. Through holding on to our ability to be amazed, to care, to look outward even when the world turns inward and cold. We survive not just by solving the universe, but by staying human within it. Somewhere, a telescope follows the trajectory of the ancient traveler. Somewhere else, a scientist builds models of possible impacts or possible passes. And those things matter. But so does this moment. One person, one window, one night. Let the headlines fade. Let the questions soften. There is no danger tonight. Only distance. Only starlight. Only the slow, spiraling hush of time unfolding. Curtains shift again. A light flickers on in the apartment across the street. Somewhere, someone else might be standing at their own window looking at the same sky. Or maybe not. Maybe it's just you. And that's enough. Let your thoughts drift freely now. Let them trace comets through the dark or settle gently in the cradle of silence. You don't need to understand everything to feel something. You don't need a reason to wonder. Tonight, the universe is quiet. It isn't calling, it isn't warning, it's just there. And in that stillness you might feel something rise, faint but real. A kind of closeness. A kind of understanding without words. The stars do not speak, but sometimes, it feels like they listen. And in the drifting quiet, one could almost sense that another secret was about to reveal itself. Chapter 15. The doomsday we carry inside. Word count, 1250. It begins not with a bang but with a hum. A quiet, constant pressure. The kind you carry in your chest without realizing. The kind that doesn't shout but lingers, beneath headlines, behind conversations, inside long glances at glowing screens late at night. The doomsday signal, once something cosmic, an object tumbling from the edge of interstellar dark, softens here into something more human. Less a warning from space and more a whisper from within. Because what we fear most may not be the comet we can see, but the collapse we pretend not to. We live in a time braided with tension. Ice melts from the poles like a slow breath exhaled. Forests burn where they once grew for centuries untouched. Species vanish before we even name them. Somewhere, storms deepen. Elsewhere, sirens rise. And inside so many, a subtle ache. Something isn't right. Compared to all that, 3i/Atlas feels almost simple. A fragment of rock or ice on a lonely trajectory, silent and cold, does not blame or ask. It just follows the physics of motion. Gravity curves its path. Starlight touches its surface. It crosses space in silence, no emotion, no purpose. Just a messenger. But what if the real message is us? What if the panic stirred by this distant visitor wasn't just about impact probabilities or trajectory charts, but about something deeper, something we carry all the time? The knowledge that the most fragile parts of the universe are not just comets or asteroids, but us. Humans, for all our knowledge and technology, are still soft beings on a thin crust of Earth. And the threats we face now, climate change, nuclear escalation, vanishing biodiversity, are not launched from space but born from our choices. Telescopes track the heavens. Satellites watch for gamma bursts, black hole jets, solar flares. We know how to read danger in the stars. But what of the quiet danger within? No spectrograph can measure the erosion of compassion. No telescope can chart the orbit of apathy. There are no sky maps for hatred, for greed, for systems too complex to dismantle and too broken to ignore. And yet, we are not doomed. Because the same species that builds weapons can also build sanctuaries. The same minds that sparked flame into destruction also launch probes to the edge of Saturn's rings. The same hands that clear forests can plant seeds. Doomsday is not inevitable. It's a choice. Not always an easy one. Not always visible in the moment. But a choice all the same. Maybe that's why we look to space when things feel heavy. Why we stare at the night sky, searching for signals. For something larger than ourselves. Something vast enough to remind us that what seems overwhelming here is only a whisper against the backdrop of time. When NASA models threats like 3i/Atlas, they calculate mass, velocity, orbital eccentricity. But beneath the data is a heartbeat, a hope to protect, to prepare, to understand. Perhaps that's all we're doing, trying to protect a fragile world from all that we can't control, and all that we can. Maybe the fear of something unknown in space is easier than the fear of what's known inside us. And yet here we are. A planet full of soft, wondering people. Dreaming, arguing, laughing, crying. Trying again and again to make it better. If the universe sends signals, then let us imagine a new kind. Not from deep space, but from here. From us. A signal not of panic, but of kindness. Not of endings, but of repair. Let it come in small gestures. A tree planted, a story shared, a child held close on a windy night. Let it come in voices lifted for the quiet, and hands extended where fear once stood. Let it be soft but steady. Not all doomsday clocks tick. Some simply pause in silence, waiting for us to choose whether to move forward or turn back. In the end, maybe the sky is not warning us. Maybe it's just watching. And the real question is not what signal the stars are sending, but whether we are ready to become a signal ourselves. A beacon not of fear but of care, of resilience, of fragile, beautiful hope. The glow faded into the horizon, but in its fading, it carried a question that lingered in every watcher's mind.